Alright, Chapter 2, Engineering Probability and Statistics, Thomas J. Flatt. Introduction. Suppose we have a bag with 3 random marbles, 5 blue marbles. Probability given the answer for the type of the question asked with the probability of selecting a marble from the bag. On the other hand, given the bag with the red and blue marbles, statistics is used to determine the proportional red and blue marbles in the bag. Based on sampled marbles with the bag, the 2 topics are linked with the fact with an eligible probability to help make a statistically based decision. For example, probabilities related with the normal random variables used to construct Z confidence intervals. The chapter review of the major topics of probability statistics typically taught with a probability statistic curve. Mode, median, mean, standard deviation, variance, combination, permutation, probability rules, random variables, binomial, random variables, normal, random variable, central limited theorem, confidence interval, mean and variance hypothesis test, single mean, design experiment, sample size, goodness of fit hypothesis test, correlation regression line, confidence interval, slope and intercept regression line. Alright, now we're going to go over to 2.1, measures the central tendency, the dispersion, combination, permutations, general probability distributions, confidence intervals, hypothesis testing, 1 mean, design of experiment, goodness, fitness of hypothesis test, regression, summary. Alright, measure the central tendency and dispersion. Often the difficulty in determining the characteristics of the large data set, hence we look at the summarize certain characteristics of the data set with the 2 numerical values. 2 such important characteristics are the middle data set, measure for the central tendency, spread of variability, measure for the dispersion, measure for the central tendencies are mode, median, and mean, while the standard deviation variances are the dispersion. Mode is the value of the data that occurs most frequently than more than one mode in the data set. Mode is easily calculated, typically isn't a very good measure. Central tendency, median is middle value of the data set calculated. The median of the data set has to be ordered either smallest to largest to smallest value. The ordered number of the data points, then with the median and middle data point is sorted list, even the number of the data points, then median, average, middle of the 2 points. The advantage of the median is that the resistance outliers, in other words, very large or small of the data point, will not affect the median. Mean, the arithmetic mean average of the data points. If the data points are sample size n of a large population, that means they're referred to in sample as given as x, the remainder x to the constant remainder of x is equal to nth log base imaginary 1 is equal to x imaginary over nth. Sample means unbiased estimated with a population mean u. Other words, an average sample means equal to population means, unlike the median. Mean is the non-resistant and outlier effect of the value of the sample. The mean way the mean is calculated. Mean is the resistance for outliers, while the mean is not a resistance to outliers. Alright, where t is a weight associated with the xi to other means of the geometric means. x1, x2, x3, the x to the nth, 1 to 1 divided by nth. With each x imaginary number greater than 0, unless all the numbers are equal, the geometric means is less than arithmetic mean, root mean square. X to the root mean square is equal to the square root of the logarithm n to the base of 1 x to the imaginary second number. If you have the data entire population standard deviation is equal to the square root of the n logarithm and the I imaginary subbase 1 x negative x imaginary number to u the population means squared over n. N is the size of the population. On the other hand, if the sample size of the population standard deviation is the square root of the n logarithm I subbase x negative 1 times x to the repeating x squared over n to the first. Sample standard deviation unbiased estimation, population standard deviation variance, simple square of the standard deviations over the population variance is population standard variance squared. Sample variance is squared to measure relative variation data set. The respective means of the coefficient variables is the standard deviation over x. The best single number numerical point estimate for population variable is x repeated at the point estimated with the standard. With the population standard is s, the sample standard deviation. Part 2, combination permutations. How many 5-card hands can be dealt with a standard 52-card deck playing cards? If we have 10 different books, then how many ways 7 books can be selected and lined up on a shelf with both questions are counting something, but there's a distinct difference. In case the card on hand ordered or important a card is on the hand, no matter how, if it deals first or last, and the card hand in the combination more specifically. Of 5 combinations set of 52 objects ordered with the cards, and the object doesn't matter. On the other hand, the books clearly have an order on themselves, or left or right. The arrangement of the books is permutation. More specifically, 7 of the permutations of the set of 10 objects is objects to note that the books have a specific order. Recall imagine n to the infinite is equal to n times the n to the negative 1 times to 2 to 1. Number of x combinations are a set of n objects can the combinations is equal to the n, the greater than equal to the number is number over x. Nx is equal to c, nx equal to the numbers of infinite, x infinite over x, kx, the combination infinite times the number times minus x infinite. If the sets for counting have no order, c times nx is a set should be listed as an order of p to the n times x. Number x permutation set of objects if it equal to x greater than equal to x greater than equal to n number. Alright, p to the n parameters nx is equal to the n infinity over n times x, over n minus x infinity. Alright, 2-3, general probability. If we flip a coin 10 times, there are a number of probable sequence we could ask. For instance, we're probably getting at least one tail, in this case sample space. Set all possible outcomes, random experiment set of the outcomes of the flipping coin 10 times denoted as S. The definite of the event E and subset sample places are given at least one tail and 10 coin flips. We use parameter E, the event, to represent probability event occurs. Note that 0 is greater than the parameter E. Parameter of the event may greater than equal to the 1 parameter times the sample space. All possible outcomes equal to 1. The event of the event and the event is either the event does not occur. The complements of the events can often be calculated as probability of the events occurring equal to 1 minus the probability of events. The complement formula is useful when calculating probability, at least at most things. For 2 events E and F, the total probability is given as probability E plus E event E and E event F is equal to probability event E plus probability F minus probability of E times F, where probability when E plus F is union and EF is intersects 2 events. Coordinate probability E is given of E given of F is the probability E over F is the probability E event E over F equals the parameter probability E event times EF over probability F. 2 events are defined to be independent if probability event over probability second event is equal to probability event first probability event. If the 2 events are independent, probability of event and first event, probability event and first event is equal to probability event times probability of event. When possible, independence assumed improbable, so that we'll calculate probability event 1 and 2 by using probability event times probability event Probability event 1 times probability event 2. Christian probability event formula written as probability event AF is equal to the probability event and divided by second event times probability event second event. Use calculate probability event first and second. Alright, 2-4 probability distribution. Random variable X is defined a numerical outcome. Random event example, the number of heads of the 10 coins, the height of the person selected random. There are two types of random variable: a discrete random variable with a finite countable number of possible outcomes, which often an integer of the expected value. Discrete random variables X is equal to E times X, and the logarithm N is equal to the imaginary unit equal to 1 times X imaginary times probability of X imaginary, where each X is the value of X imaginary is possible value of X. Probability X imaginary is equal to probability X equal to probability X imaginary. More general function GX is equal to E event GX equal to the logarithm N logarithm and imaginary I GX times PX imaginary. Continuous random variable has this density function fx is such as the probability that a greater than or equal to x greater than or equal to b is in the derivative function x is equal to the differentiation x. Two common random variables are binomial discrete normal, which continuous expected value of the continuous random variable x is event 1x is equal to the derivative of xf times x times the differential x, again with the function gx, and event gx is equal to the derivative infinity minus over infinity over negative infinity function gx fx times fx function fx is the derivative of x. In both cases, the formula event 1 gx can be used in each example. Calculate event x squared by taking gx function gx to the x squared. One application of the expected value is that with the density function given the mass of an object, then expected the value at the center of gravity of the object. To know the density of a function, we must use the function x is greater than or equal to 0 and the derivative function x, the derivative of x is equal to 1. Binomial random variable arises when your experimental fixed number of observation trials. Each trial resolves the two possible outcomes referred to success or failure. Each failure is independent. Then the probability of success is p is the same with the observation or trial. If x is the number of success in the trial and n trials, x is the binomial random variable with the n trials. Probability of success of p. Possible outcomes of x are 0, the subset 0 to 1 to the nth. Binomial random variable simply counts the number of success and the number of trials. For possible outcome parameter, probability x is equal to a, c, the x and y points, number of a, variable a times probability to the a 1 minus probability to n minus a. Normal random variable, which means u standard deviation has the density function. Your fx function x is equal to 1 over density function times the square root of 2 to the pi times e to the negative x minus normal random variable squared time divided by 2 times the deviation squared, 2 to the deviation squared. Normal random variable associated to bell-shaped curve because the shape of the graph of the density function bell-shaped. Both of the normal binomial random variables regularly give the model real-world situation. Two independently random x1 and x2 are each sample of normal distribution, which means of normal random variable 1 and 2, standard deviations 0, density function 1 and 2. However, normal random variable x and plus or minus normal variable x2 equals variable normal random variable 1 plus or minus for normal random 2, and density function squared equal to subset x1 plus x2 is equal to deviation density function 1 squared plus deviation density function 2 squared. When calculating standard deviation with the sum of the difference, two independent random variables must first add the variance and take the square root. We cannot add deviations. Moreover, central limiting theory of the x1, x2, and xnth independent identically distributed random variables, meaning u standard deviation, and then for the nth larger or each x1 normal, x is repeated to if x1 plus x to the 2 plus x to the nth, normally distributed over n number, n means of distributed random values and standard deviation values, density function over normal random variable, density function over the square root of the n. When applying central limiting theory, do not forget to divide by the square root of n for the standard deviation. Alright, 2.5, confidence intervals. A soda dispenser is designed to fill 16-ounce cups with the soda with the two dispenser working properly. Same 8 cups filled with the dispenser obtained the following data set: 15 to 7, 15 to 8, 16 to 1, 16 to 0, 15 to 8, 16 to 2, 16 to 1, 15 to 8. Best estimate average amount of soda per cup is given as x to the remaining x, 15.94. Point estimator single numbered with a sample they used to estimate population parameter u based on the 15.94 estimate. It seems that the dispenser underfilling the cups. Unfortunately, we do not accurately the point the estimator construction with a confidence interval addresses the problem. Level A level 1 minus A to the percentage confidence interval of A and B for a population mean of the u is internal interval constructed so that there is a to negative a 1 times a to the 0 negative percent chance for the containing the population means. The confidence interval is constructed with a highly likely the parameter is an interval somewhere where they cannot be assumed with the middle of the interval. If the population standard deviation is unknown, its sample data density is unknown, the sample data roughly bell-shaped population means of the u normal random variable estimated with a t confidence time of the confidence interval, which was constructed by x minus ta divided by 2 to the n1 over the s over the radical n. X repeated equals time of variable a divided by 2 n to the first s divided by n radical n. We call the t confidence interval or t interval or ta over 2n1 construction interval, since the theory tells us that the density is unknown distribution sample mean fits the confidence interval with a number of 1 and 1 degrees of freedom. On the other hand, the population standard deviation density is known that the sample size of the large, at least 30, typically acceptable, where the population is normal. The population means of normal deviation estimated with z confidence interval was constructed by x remaindered by z, the confidence interval over a to the second times the density over the radical over the number of times x remainder plus the confidence interval times the a over 2 times the density over the radical of n number of tries. Interval is called the z confidence interval. Z interval was ZA2 in the construction, since we're using central limit theory, which shows that e with the assumption distribution of sample means normal. In this case, we basic confidence interval 1 minus 8% level of the margin error e half the width of the interval. The size of the sample needs to be calculated as n is greater than or equal to the confidence interval times the density over the event squared. Similar estimate the difference two populations of the u1 and minus u2. The independent population from a variance is unknown with the two sample time t intervals. And then it shows when n and n2 are sample sizes, two samples, and s1 or s1 of the second, s2 the second are variance of each sample. You have s to the second over probabilities, which is n to the 1, n1 minus 1 times s1 squared plus n to the second n minus 1 times s2 squared, n1 plus over n1 plus n2 minus 2, where the interval density is unknown and the confidence interval is known. Population variances are also sample of confidence interval. And it goes into example. Move on to 2.6, hypothesis testing for one mean. Again, using our soda dispenser data, we simply ask the question, soda dispenser filling up the average 16-ounce soda. One way to answer this question, a hypothesis test carry out with a hypothesis test, we choose the level of significance A, state with a multiple alternative hypotheses, calculate test statistic critical value, compare the test statistic critical value, decide whether or not there is sufficient evidence to respect the hypothesis 0. No alternative hypothesis statements are unknown parameters such as the normal deviation and density population parameters. As with confidence intervals of the test we choose, it depends on whether we know of the population standard deviation. From the soda dispenser example, we shall choose the significant alternative parameter hypothesis as 500, which is common in the null hypothesis of the null hypothesis is an alternate per process. State that the null and alternative populaces the null is 16, which read the soda dispenser fills each cup average 16-ounce soda. The alternative hypothesis is that the normal density deviation occurrence is not equal to 16, which if the soda dispenser does not fill each cup of 16-ounce sodas. Both hypothesis statements are about population mean, which means the dispenser actually does and point out the hypothesis test and determines the hypothesis most likely to be valid. The t-test, in the case of the population standard deviation, is unknown. The test statistic is the test is equal to the x continuous x minus the normal deviation 0 over s standard deviation divided by the square root of the number of tries, which is u to 0 value against the testing population's mean. The testing population x variable repeated x to the infinite to the number x unlimited over the normal deviation over standard deviation standard time divided by the number n of the r square root of n. So the two-sided test, critical value of the plus or minus ta to the 7 equals plus or minus 2.365 test statistic time t 0.917 of the critical values. Otherwise, words t is greater than or equal to negative ta to the 2 to the 7, or t is greater than equal to the a over 2 times 7. The null and the alternative pair, which rejects null hypothesis, favor alternatively. Otherwise, we fail to reject null hypothesis. Example: we do not reject null hypothesis. The null hypothesis is the normal randomness of over 0 greater is less than normal random is 0, and the alternative hypothesis is the randomness of greater than 0 tries. One side reject null hypothesis in the interval test statistic. In second case, the only difference of the t-test is case the population standard deviation is known. Test statistic would be population standard is equal to x. The number of tries randomness is equal to normal deviation over density divided by the square root of the number of tries, critical value given. ZA, the z-test, the two-sided case of plus or minus z. In one case, sided case, depending on the inequality of alternate hypothesis. Alright, 2.7, design experiment. Let A, probability type 1 error, also know level of significance, B, probability of type 2 error. If you want the hypothesis test 1, normal relative to the normal random variable is not equal to 0. Population means the normal random variable 1. Then need the sample size of the normal number of tries is congruent, greater than or equal to or approximately ZA squared plus Z to the Z, the type 1 error time plus type 2 area squared over the density squared over the normal random variable 1 minus normal random variable 0 squared. Similarly, if you want the hypothesis test of the normal random variable is greater than 0, population mean with the normal random variable, then the sample size needs to be the number congruently of test type 1 area minus type 2 area times the density squared times normal random variables 1 minus normal random variable 0 times 2. No more likely the researchers want to be able to detect the difference in mean, so valuable normal random variable 1 minus normal variable 2 is known. Alright, 2A, the goodness of fit hypothesis test. According to M&M's.com, colors of plain M&Ms are packaged accordingly. A percentage of the table of the test that claims that number of 50 M&Ms to obtain with accounts of the observed column of the table with a perform goodness fit hypothesis test, null hypothesis claim distribution, multi-nominable probability given an M&M are correct. The alternative hypothesis is at least one multi-nominal probability does not equal the hypothesis value. So the table in a good way organizes information due to the calculation. Color claim observed expected, observed minus expected squared over expected. The observed column is given in our sample. The expected column is calculated by multiplying the size. Sample size 50 in this case claimed the probability with the test statistic is x squared equals the logarithm observed minus expected divided by observed minus expected squared over expected. In this example, the 4.684 value bottom right side, null hypothesis, the x squared equals x to the a, the k to the first, k minus 1, x and x2 is equal to a, k minus 1, where x1 is the degrees of freedom, x is the number of the categories is found with the chi-square table, where a 0.05, we get x squared 0.05, and out of 5 rationality 11.0705, hence we fail to reject the null hypothesis. Alright, 2.9, regression. For data sets of pairs of the x imaginary and y imaginary sample correlation coefficient, r is equal to x sx s to the sxy over x over the radical of sxxxyy, where xxy is the logarithm of n negative 1 x1 xy x imaginary y imaginary minus 1 divided by number of tries, logarithm n imaginary 1 times x to the imaginary, and x logarithm n the base of the imaginary 1 y1. So x sxx is equal to the logarithm n to the base 1 x2 squared minus 1 equal to 1, plus or minus negative over number a try data set logarithm of the n to the nth over the negative 1 times x to the negative x imaginary squared, and SYY is the logarithm n, logarithm to the base, the nth imaginary equals negative y to the squared minus 1 to the negative 1, and measures linear relation between two variables. Value of 1 or negative 1 means the perfect linear relation, while the value of 0 says there's no linear relation. But if the linear relationship, then linear regression is given by y equals a plus bx, where b is equal to sxy over sxx, and a is equal to a remaindered y and a by minus b remainder, continuous y minus b times x continuous. Residual particular data set, x imaginary, y imaginary is equal to y imaginary minus y times x imaginary. The regression line is for which sum of the squares residual is minimized confidence interval slope of the intercepts are given. Then it shows the quadratic formula. When calculating S, make the table for the columns xy, x2, y, and xy with the sums of the columns values needed. Alright, 210, summary. Probability statistics are tools decision making in statistics looking at obtaining information on unknown population parameter. We may want to know over the coin fare mean amount of soda machine puts into a container, mean household income in the country. In case for the parameter unobtainable for one reason or another, we cannot know if a certain coin is fair. Soda dispense with the design to put a certain amount of soda container that could be defective. There are too many people the same sample to know the mean household income. In each case, we are statistical techniques based on probability to estimate parameter, make it a decision. For instance, binomial random variable show the probability of attaining 9 or 10 tails and 10 flips of the coin as of 0.01. Hence, if the coin is unknown to be fair or not, the flip 10 times during 9 or 10 tails occurs would decide whether the coin is unfair, since it's unlikely to observe the many tails with a fair coin. This is generally the idea hypothesis test, which we use to assess the fairness of our coin. Sort of machine is dispensing correct amount. We assume that the null hypothesis is true and calculate the likelihood of our outcome comparing test statistic critical values, similar confidence interval estimates parameters with 90 to 95% accuracy. Hence, we estimate the means of the household income with a sample with both hypothesis of the test and confidence intervals. We can obtain information unknown parameter used this making the decision. Practice problems. Chapter 3, Chemistry.